Hey everyone, let's continue with chapter 3. This is page 3 in the chapter 3 notes. More examples of probability. Here we have a probability conspiracy, a probability experiment consisting of rolling a 6-sided die and tossing a coin. So we got two objects now. Right, we've got that same 6-sided die from before, but now we're introducing a coin. Coin can land heads or tails, so there's two outcomes on those. What's the sample space? So we've got a lot of things going on there. If I blow this up a little bit, like what are all of the possibilities? Well, I could get heads and a 1, right? Heads on the coin and a 1 on the die. Or I could get heads and a 2, or heads and a 3. All of these would be different outcomes, right? And those are all of the possibilities of getting the heads on the coin and then something on the die, right? So now let's move to tails. So I could get tails and then each of the 6 numbers, right? And there you have it. And with a little squiggly. There are all of the possible outcomes, right? One of those 12 things is going to happen and no other, and they are all different. Okay, so that's my sample space. Okay, once you have the sample space, it makes answering the probability questions easier because it's just counting up the outcomes in your sample space. So find the probability of rolling a 3 and tossing tails. So let's do some probability notation. Probability of 3 and t. All right. Well, there's only one of those, right? It's the T3, that guy. Why did I erase it? I meant to highlight it. Let's undo that. There it is. Okay, so that's the one I want. So there's a 1 out of total number of 12 possibilities in that sample space. Okay, and I can leave that as a fraction, or we can do it as a little estimated proportion, or even move that decimal 2 places for the percentage, 8.3%. Any of those would be fine. Is that event simple for part C? Yep. It's simple because you have a 1 in the numerator. There's only one way to get that event to occur. Okay, how about D? Find the probability of rolling a number less than 4 and tossing heads. Okay, so probability of, how about we'll go less than 4 and an H. Okay. So if I go back to my list, I got to find those. Less than 4 is not 4, but just 3 or 2 or 1, and it's got to have heads. So that's those 3 right there, right? So there's 3 possibilities out of 12, which I can reduce that to a fraction of 1/4, write that as a decimal of 0.25 or as a percentage of 25%. Is that one simple? Nope, because there are 3 possible ways to get it. So no. Okay, so that one's not too bad once you get that sample space written out. And that's similar for all of these. I mean, once you can get that sample space, you are on your way to answering questions about probability, all right? Okay, next one consists of tossing 2 coins at the same time, this probability experiment. Find the sample space. So to help you with this one, think of the 2 coins as different objects, right? Maybe like a red coin and a blue coin, 2 completely different coins. Now I can think of a couple right off the bat. I can get heads on both the red and the blue coin, or I can get tail on both the red and the blue coin, okay? And then the rest, okay, I could get tails on the red coin and heads on the blue coin, right? Tail, head. Or I can get heads on the red coin and tails on the blue coin. That would be HT. Those are different outcomes. And you have to think about that for a minute because it kind of seems like they're the same. It's one tail, one head, but they're different because of where the tail is and where the head is on which coin. It does switch, right? Because you have two completely independent, separate objects. Okay, so the total number of outcomes in the sample space is 4. Now we can find the probability of getting heads on both coins. So that's the probability of HH. And that's only going to happen one way out of 4. Right? So that's 25% chance of happening, right? How about the probability of getting exactly one tail? Right? So you're rolling, remember you're rolling 2 coins and you get exactly one tail. Well, that would be that and that satisfy that description, right? So probability of one tail is 2 possibilities out of 4, right? That's a half, or 0.5, or 50%. Good to practice all those ways. How about the probability of getting at least one tail? Ooh, at least one. That's always tricky wording, okay? So probability of at least one tail, at least one. What does that mean, at least one? So at least one is one or more, right? So if that terminology messes you up, because that comes up a lot in this section, at least one is one or more. One or more. So I'm looking for any of these outcomes that has one tail or more than one tail, right? And so that's basically just means there's a tail in it, right? So that's the 2 I already have highlighted and this one, right? All 3 of those have that property. So this one, at least one tail, is 3 out of a total of 4, 0.75, 75%. Okay. And that's that one. All right, we're moving right along here. The next one, we're going to ramp it up a little bit. We're going to do 3 coins at the same time. All right, probability experiment. Oof, find the sample space of that one. Okay, a good way to do that is let's start with 2 coins, because I know it's HT, HH, HT, TH, or TT, right? That's if I have 2 coins. Now we're introducing a third coin. That third coin could be a head or a tail, right? So what I'm going to do is attach a head or a tail to all of those possibilities. For example, if I do H, that would be those outcomes. Then I'm going to repeat that HH, HT, TH, TT, and now just attach a T on all of them. And there I have my 8 possibilities. There's my sample space. I'll just say it's over here. Okay. You can take a look at them now. I mean, that's a kind of a systematic way to get them all so that you don't have to sit there and, beat your head against the wall trying to come up with all these possible outcomes. Okay. Once we have that, I mean, now we can just answer the questions. Find the probability of getting heads on all 3. That's just that one, right? So it's 1 out of 8. What's that? 1 divided by 8. Oh yeah, 0.125, 12.5%. All right. Exactly one tail. What's probably getting exactly one tail? Let's see. Let's do this with highlighter. Exactly one tail. There's exactly one. There's exactly one. There's exactly one. There's 3 of them. 3 out of 8. 0.375. 37.5%. Find the probability of getting at least one tail. All right. Let's see. Let's just do this circling in orange or something. At least one tail. At least one tail. At least one. At least one. At least one. At least one. At least one, at least one. At least one is one or more. So one tail, two tails, or three tails, right? So it's all 7 of those. Right? Notice the only one that doesn't have it is the HHH, no tails. Good thing to note here is those are opposites, or what are called complements. Right? At least one is the complement of none, because they're exactly opposite. At least one is 7 out of 8. None is 1 out of 8. 7 out of 8. 0.875. 87.5%. Okay, so I'm going to stop there. That's another little addition of doing some probabilities. Hope it helps. Let me know if you have any questions. I'll talk to you soon.